All right, I think we're ready. We're good to get started. I think it's as big as this is going to get. So, hello, welcome to CSCI 40. I'm so excited to teach you cool computer science stuff. The reason I'm not making this PowerPoint full screen, by the way, is I get much cooler pens if I do not. Very happy about that. So, first of all, don't feel like you need to write down every little thing I say. I will be giving you all these slides, all the code that I write in class, everything like that. You're even going to get a video, because why not? So just write down the important stuff. All right? And so today is that, silly little intro lecture where we have to spend some time, unfortunately, on just administrative stuff, and then we'll get into the good stuff, okay? I'll teach you a little bit of programming later as well, so look forward to that. I think the first thing that I should do is at least introduce myself. So hello, everyone. My name is Lawton Nichols. I use he, him pronouns. And I will respond to whatever you want to call me. Like, you can call me Mr. Nichols, you can call me Dr. Nichols, you can call me Professor Nichols, if I can spell. But I would prefer it if you would just scrap all these and call me by my first name, please. Please just call me Lawton. So, yeah, a little bit about me. I went to Fresno State for my undergrad, got a computer science degree there, not too far away. And then I went to UCSB, UC Santa Barbara, for my PhD. So I have 3 degrees in computer science. Hopefully I'll be able to teach you something, right? We're going to edit these on the fly because it is now my 3rd year here. Yay. It's a new school year. And it's actually only my 2nd semester back on campus. Surprisingly, I got hired during the pandemic. It's very weird. I like to do human things as well as technology things. I like to dance. Actually, I have a dance lesson tonight after my office hours. And I like to play guitar, among other things. And this is my cat. His name is Lonzo. This is from when he was a kitten. He's much bigger now. But he was named after Alonzo Church, who was the PhD advisor at Princeton of Alan Turing, which is a name you probably have heard before. Okay? I owe a lot to that man. I also have 2 beautiful moss balls without names. Maybe you guys can help me name them. So yeah, we are what? Mid-post-pandemic something? It's still an interesting time to be alive. So definitely thank you in advance for putting up with me. It's going to be another interesting semester, I'm sure. But we'll get through it together. Okay? So let's talk about information. So this is an in-person class. So let's talk about all this stuff. I am, for some reason in college, required to take attendance. So we're going to do that in a little bit. And one thing I'll just say right now is you can leave if you're done with your lab. There's going to be a lecture portion and a lab portion of each lecture, and if you're already finished with all your work, you totally don't have to stay and stare at your screen. So I hope that sounds fair to you. My drop policy is if you miss the very first class or 3 consecutive classes after that, I will drop you. So pretty lenient, but just make sure to show up, okay? And I will, of course, excuse absences due to illness, etc. Just let me know. And yeah, I like to have the lab start whenever the lecture ends, and so that's how we'll transition. We'll have like a little break in between as well, because this is a longer class. Okay? So, this is not an online class. Let's talk about expectations, because this is a bit of a challenging class. It's a 4-unit class. Programming is very different if you have never done it before. It's a new way of thinking. It's going to make your brain hurt for a little bit, okay? So, just want to make sure you're aware of that. There's going to be a bit of work as well. I have a lot of things that I'm required to teach you because this is your first programming class. So I have to get you up to speed and ready to succeed in future classes, okay? One thing, though, that may or may not be nice is that this class has nothing to do with memorizing things. Like, all you have to do is learn how to think properly. Learn how to think like a computer, and that's what I'm going to try and teach you, okay? So there's no need to memorize things. It's all about learning how to think computationally. That's the fancy word that we'll talk about later, okay? If this gets to be too much, it is a 4-unit class, it is some work. We do have CSCI 1 offered here that I encourage you to take if CSCI 40 is not the class you want to take right now, okay? It goes over programming at a much slower pace. This is a major class, and it goes a bit faster, okay? So, in case you haven't heard this rule before, let me just tell it to you now. Like, this is a 4-unit class, which means we're going to spend 4 hours a week in class, and that translates to double that unit time of hours outside of class. So you should be spending 8 hours outside of class working on stuff each week, okay? And you might very well get up to that limit some of these weeks for this particular class. Okay, I just want to warn you, make sure you're aware. All right, so that's expectations. And I'm, of course, not trying to scare you away. I want you guys all to succeed, and I know you all can. So I will be here as much as possible to help you. I'll be available all the time. I'm on Discord way too often, probably more than I should be. So I'll make sure to be here. Okay? It's going to work out if you put in the work. Promise. Let's keep on trucking through all this administrative stuff. Let's talk about the technology loan program. So the library, if you haven't heard of it yet, they let you check out laptops. Even if you have a bad internet connection at your home, they'll let you check out a wireless router that uses like a cell phone tower to connect to. I think it's called a MiFi router, if I remember correctly. So look into those things if you need those things. We have plenty. They're all for you. And for other classes, I'm sure they have calculators to check out and stuff like that too. So definitely take advantage of this if you need it. And then I think this is probably the slide that you care most about. So let's spend some time here. So let's talk about the syllabus. Yay. I'll go to the part of it that you probably care most about. So I'll go to the modules page. And we'll go down to syllabus. And I'll try to make it as big as possible. Open in browser. All right. So here's the part that you probably care most about. I'm going to go through this fast, so definitely remember to read it. Do your part and study these slides at the end of the day. But here's how we do it. So you will have homework and programming assignments pretty much every week. There will be reading assignments from your Xi book. That'll be 10% of your grade. There will be Xi labs from your Xi books. Those are programming assignments directly on your textbook, another 10%. And then the biggest chunk of your grade is going to be programming assignments on our class server. Okay, so that's what all this other stuff, all these other assignments are getting you ready to do. Okay, that's going to be 25%. And then you should have seen this already. 5% of your grade is going to be from those little check-in surveys. Did you see that on the modules page yet? That's this one. Here's your first week's check-in survey. So it's a very easy 5% of your grade. All I'm doing is forcing you to psychoanalyze yourself so that you can think about, okay, what are you struggling on? How can you improve? What do you need to do to get over that hurdle? Okay? I think that's really going to help you. It's also going to help me understand what's going on with you. Okay? So it's good for both of us. Let's talk about midterms. Where was I? Here. There will be 2 midterms in this class, each worth 15% of your final grade. And I'm going to try and make them be on week 6 and week 12. Okay? So that's like 1/3 of the way through the semester and 2/3 of the way through the semester. So that at the very end, 3/3 of the way through the semester is the final. That's all evenly spaced. That's the plan. And then 20% of your grade will be the final. Okay. Any questions about this? Just shout them out.
I have a question about the assignment that's going to be submitted on the class server. Is it has to be done in class?
It does not. No. You can connect to the class server from your own computer.
Thank you.
Yeah, there definitely won't be enough time in class to do it all there. Yeah. So there will also be extra credit. I like to give extra credit around exam times, and throughout the course of the semester, I like to give at least a letter grade's worth of extra credit. So look into that if you need it. And then we have a final exam date because this is a scheduled class. Let's scroll down to this. So I just looked this up on the table on the school's website. Apparently, our final exam will be on Tuesday, December 6th, from 3 p.m. to 4:50 p.m. So we'll be in this room, we'll take the final, and that'll be that. Okay? Any questions about any of that? Please just shout them out. Probably the most important slide for you right now. Feel good? All right. So let's keep on trucking until we can get to the good stuff. Let's talk about due dates. This is something that I like to do a bit differently to other professors maybe. This is what I want you to plan on. Every assignment in this class, except for the check-in surveys, which will be due slightly later, will be due at 5 p.m. on their due date. It's not midnight, it's 5 p.m., okay? And the reason for this, if you've never programmed before, and I assume most of you haven't, is so many things go wrong near the due date for a programming assignment. That will happen, okay? So let's just make sure I'm awake. I will actually usually be in office hours around the due date time, so I'll be able to help you when those problems occur, okay? And then we can all have a weekend after 5 p.m. on Friday as well. So that's why I do that. And so plan on having things due at 5 p.m. Unless one of the following exceptions applies to you. I think we can all agree that these are fair. So here are my 2 exceptions, and please let me know maybe after class, maybe in a Discord message, if any of them apply to you so that it can get you the extension that you very much deserve. So if you work at least half time, so 20 hours or more a week, school does not count though. If you're taking 20 units, that's totally your fault, right? Then I will give you an extra 7 hours to do your assignment. So you can stay up late. It will actually be due at midnight. Otherwise, if you work at least full-time, 40 hours or more a week, or if you do something else that is the equivalent of a full-time job, like you care for a child, something like that, then I will give you an extra 15 hours on your assignment. So you can stay up late or wake up early and get it in. Okay? So please let me know if any of that applies to you. You definitely deserve that extra time. Okay? So that's that. That's due dates. Let's talk about late submissions, get through all this stuff. So I am pretty lenient with late work. I will accept late Zybooks assignments, labs, and check-in surveys up to the last day of instruction. So that's like the week before the final. So you're welcome. But there is a catch to that. The second something is late, you only get half credit at most. 50% goes away. Okay? So I hope that seems fair to you. 50% is definitely more than 0, right? So you can get things in if you miss things. All right, for half credit. One thing that's weird about your Zybooks, the way that it transfers the grade to Canvas is very odd, and I can't see it when you submit something late. So it'll usually mark itself as a 0. You just got to tell me to go back in and notice that you deserve your half credit. Okay, so just let me know if you turn something in for Zybooks that's late. Usually I'll see the labs and I'll see the check-in surveys pretty easily. Okay, but just keep checking your grade. Yell at me if something seems wrong. All right. I'm also pretty lenient about assignments, so I'll drop a few. So I will drop your 3 lowest labs. Those are the programming assignments on the class server. I'll drop your 4 lowest Zybook readings assignments, and I'll drop your 4 lowest Zylabs textbook programming assignments. Okay? So if you do poorly on a couple labs, it'll be like they never happened. Okay? So you're welcome. And I think we're ready for the Zybooks itself. So I've been saying this word. Hopefully we've been able to purchase the book by now and be able to see it, right? Probably the easiest way to get it is to go here, to go to one of your first assignments, like Chapter 1, Chapter 2 assignment. And then you just click this, and it should take you to a link to buy the book. Okay? So let me go there, Zybooks. Library.zybooks.com, something like that. Shoot. Well, I'll find it one way or another. I think this is an old class version, but let's go back here. My library. There we go. So here's our Zybook. It's very beautiful. It's definitely the best textbook I've ever seen for this class, so it's really worth buying, I promise. You can look at your assignments in this tab. It shows you exactly what's due for this particular assignment. Like these sections are the ones you have to read. These are the point breakdowns, all those things. So definitely look at that. And let me show you just a little sample chapter. I don't know. Let's try this one. So, of course, there's words, but there's also lovely, lovely little concept checks. And also, and this isn't a good chapter, I guess. It's too short. There are beautiful animations, which make it so much easier to learn things. Like you click start, and it shows you exactly what's going on inside of your computer or whatever concept it's trying to teach you. It's so much better than how things used to be for these classes. Okay, so it's really going to be nice, and I encourage you to pay attention when you're reading this. Don't just do it for credit, okay? I'm pretty sure it's easier to buy it from the Zybooks website, but it's also available in the bookstore. Definitely check the prices and things like that. I have heard horror stories from students, though, like it takes a million years for the bookstore to give you an access code. Question? This is a virtual textbook, so that makes no sense at all. So definitely contact them. Say that again? Yeah, please contact the library then, because that's not right. Usually at the beginning of the semester, they're ready with little codes, and last semester I think they had to physically send you a little scrap of paper with the code on it in the mail. So that's very unfortunate. But that's what they did in the past, and that should be the case. If too many people have trouble, I will contact the library myself. So keep telling me if things are going wrong. Okay. Yeah. So look into that. And yeah, I've actually put all the assignments up if you have no life and you want to get started. All these down here. It's better to do it early, that's for sure. I've definitely front-loaded a lot of the reading work in this class, and I think you'll thank me for that as the semester gets to the end and you have to worry about finals. So there's going to be a lot more reading right now than later. Okay? I think that's better in the long run, though. All right, so that's SciBooks. Let's talk about Discord. That's how I want you to interact with me and with your peers. Let me open it up. This is not the world's fastest computer, but it will get open in a second. Hopefully we've all been able to make an account, join the class server, click the right buttons and all that, but I'll go through it right now once it decides to start up. That's promising. All right, so here is our class server, or our class Discord server. And once you first join it, it's going to plop you into the welcome channel, right? And you just scroll up to the top, and you click the 100 emoji, and you click the cat, and you add your pronouns, and then that should unlock all these things down here. So you got like general and random. Where I want you to live mostly is going to be in the CSCI 40 channel. That's where I want you to post your discussion questions, things that you are wondering about, and all of your peers can see if you post it there. Okay, so that's public stuff. I encourage you to ask as many public questions as you can so that your peers can help you while like I'm sleeping or something, right? So take advantage of that. The one thing that I don't want you to share publicly, though, on Discord is like answers to a very long question, a ton of code. You can share a few lines, that's fine, but definitely use your judgment because it's not fair to be sharing answers with other students, okay? So I trust you to do that right, but I might have to delete some things if we do it wrong, all right? So just keep that in mind. Try to ask public questions when you can, all right? If you have a private question, like you want to talk to me about all of your code, like all this is not working well together, then that's the time to ask me a private question through a direct message. Just send me a DM on Discord. You should be able to like click my name, click the message button. I don't think I can do it for myself because I can't message myself, but that's the idea. Okay? So I highly encourage you to use Discord instead of using email or Canvas messages because I think you can imagine that as a professor, my inbox is so ugly. But Discord is super nice because I can see like I need to respond to these two students right now. Okay, so that'll be, that's how I work. Question? What's that? There's a link on Canvas. I have no clue. I think I can't just give you the name and it works. You got to go through the link, through the Discord info. But it is called Lawton's class. Yeah, any other questions? All right, let's keep on trucking. Almost done with this, promise. So I want you to go to office hours as well when you have questions. Please, 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 please. Here's my office hours schedule. At least when I want to have them right now. All this stuff in green. So I'll actually be having office hours right after class today if you'd like to follow me to my office. So I will also try to have them on Zoom as well. So I'll if you don't want to be here in person with me going to my office, you can go home, get on Zoom, and I'll be there as well. Okay, so for all of my office hours, these are when I want to have them. You can expect to find me on Zoom if you just click the link. All right. What else do I want to say? It might take me a while to go between class and my office, so it might take a little bit of a lag time to get on Zoom after these class ones, but this one I'll be on exactly at 4. Okay. That is my plan. So come to those if you would like. I highly encourage it. And then I think finally, before we do actual computer science stuff, let's talk about getting help. So in addition to office hours, of course, this is a new way of thinking for a lot of you. Programming is weird. So you're going to get stuck on some problems, and that's totally fine. That's to be expected. I don't want you to stay stuck forever, though. Okay, so let's pick an amount of time. If you've been stuck on a problem for 30 minutes, let's say, half an hour exactly, and you're not sure where to go from there, you're completely stuck, please, that's when you should ask for help. Go to office hours. Ask me something on Discord. Post something publicly on Discord. Go to the tutorial center. Do something to solve the problem, okay? I'm here. I'm here to get you over that problem and on to the next one, right? So please, please take advantage of all the help that is offered to you through me, through my class, and through the school in general, all right? So There's no virtue in staring at your screen for 2 hours, right? That's not going to get you anywhere. I want to get you moving on to new, bigger problems. Though, being stuck for 29 minutes is exactly what I want, because that's how learning happens, right? So that's how that's going to work. You're going to get stuck for short periods of time, have a flash of genius, and then move on. That's what I want to have happen with you and your brains. Okay? So that is, I think, all the administrative stuff that I want to talk about. How are we doing? You good? Good to move on? All right. So the next thing that I want to do is talk about the class website. So there was a link. I don't know if you followed the link or not, but I've made you 2 separate accounts. You've got the class server, which I've talked to you a little bit about, but those are 2 separate accounts, but you have the same username and password by default at the beginning. Okay? That's what I want to tell you right now. So if you changed your password on the class server, it had nothing to do with the class website. Same username and password by default at the beginning, but different places, different real accounts. Okay? That's the idea. So if you already changed the password on your server, did nothing to the class website's password. So please, everyone, go to this beautiful website, www.lottensclass.com. It'll ask you to log in, and your username and password are right now your last name, all lowercase, and then an underscore, and then your student ID. So if this is your last name and this is your student ID, this would be your username. If this is your last name, if it has some hyphens or accent marks, you get rid of those. And you just put it like this, underscore student ID. This is your username and your password right now, unless you've changed it. So please, everybody, try to log in. I don't think anybody has added the class after Friday, but let me know if you have, because that means you don't have an account yet. This will be how we take attendance. So I'll give you a couple minutes to get that on, get to the home page, and then we'll do attendance in a second. Good old self-service, still not working. So silly. Is anyone having any trouble logging?
Password the same, your last name, underscore the
I think we're ready for attendance. So this will be how we take attendance. Is my question first. Are you having trouble? Oh, okay. Now we should all be happy, yes? No. Okay. All right, we're never gonna have problems again now. It was worth it. So please tell me after all that work that you are here. Click any link, does not matter. Any button after you go here. And I'll give you like 30 more seconds to do it because we should all be there. But this will be what we do at the start of class from now on. Okay? Remember, I do have to drop you if you do not click a button right now. So has anybody not yet clicked a button? Going once, going twice. We're all here? Shout right now if you have not yet clicked something. All right. End attendance. Yay. So you should now be able to click view my attendance and just confirm that you're marked here and you won't be dropped and life is good. Yay. Hopefully that will come a bit more naturally next time. Yeah, put it way over here. Go over there. That's what I'm talking about. All right, so thank you all for getting through that with me. We're ready to move on to actual C++ now, maybe? Yay. All right, let's do the actual lecture now. Let's talk about computers and C++. So right now, we're in here till 5:45. We'll do our best. So, yeah, I'm going to throw a lot of information at you right now. Again, you don't have to write anything down. I'm going to give you all these slides. I want you to study the code that I write today, though. It's a new way of thinking, that's for sure. Okay? So, before we get there, I'd like you all to introduce yourselves to your peers through this little bi-clicker app that I have made. So we're going to go there in a second. And so I like to give a lot of in-class exercises for you guys to work on, sometimes in groups. So the reason I call it bi-clicker is because maybe you've seen this. It's like a very expensive thing called an iClicker that you see a lot in like big physics classes, chemistry classes, little exercises like that. So I have made a free version of that for us. You are welcome. That is computer science efficiency. So we'll go there in a little bit, and sometimes for these questions I'll split you into groups and you will work on them with your peers. That's called peer instruction if you haven't heard of that before. All of the research says you learn so much better that way than from listening to me yell at you. Okay, so that's why we do it. That's why it's happening. And so our first question is on the next slide. It's an in-class exercise or an ICE, and of course our mascot here is the crush, whatever that is, some kind of bowl, right? So naturally, I'm going to combine these two words, and our in-class exercises here will be called crushed ices. Yeah. So let's introduce ourselves to our peers. Please go to your bi-clicker app and click the corresponding answer. What is your major? Let's get that out of the way. That's what everybody asks everybody else when they first meet somebody in college, right? So let's see what the makeup of this class is. There should be a decent spread for this class. It's a requirement across a few majors, that's for sure. Give you another 15 seconds, just in case you're not sure yet. I think I can look at the time from this little mini thing. Yeah. All right. Let's see who we are. A lot of us computer science majors, welcome. And then we have a little bit of everybody else. Nice. So at least 2 for every other categorization. So welcome, everyone. Your presence makes this a more diverse group, and the class will be more fun because of it. All right, let's talk about the next thing. So we will be using the Linux terminal or the Unix terminal in this class. Tell me if you've ever used it before. I'm going to get you to be very, very acquainted with it, one way or another. I do not require any knowledge. You're not supposed to come in with any, but let's see where we're at. Let's see here. Honestly, don't even know if I would answer E. I know people much better than me. All right. Yay, look at us. So most of us are A, and that's exactly where I want you to be. Everybody else who has some experience, especially the person who picked E, help your peers. Peer instruction, right? All right, last question before we get into the actual lecture content. Please tell me if you've ever programmed with C++ before, because that will be the language for this class that I'll teach you. Maybe you can fill in for me if I get sick. You pick D. Give me another 10 seconds. All right, so, yeah, this is all one long lecture. So, let's see where we're at. Boop. Look at that beautiful graph. Nice. It's just perfect little line. So, some of us have seen C++ before. Others have a decent amount of experience. Thank you to the person who picked D. You can be my sub if I ever get COVID. So, yeah, I expect you to be an A, but again, B, C, and D people, help your peers. They will love you forever. So, yeah, that's where I want us to be. Sounds good. Now you know a little bit about your peers. let's get on into the actual lecture now. All right, so let's talk about programming. Are we ready to learn some real computer science? Let's do it. So the first thing I should say is, what is a program, right? A program is not too bad. It's just a recipe for something. You want to make something? You have a sequence of steps to do that thing. Another word for this is algorithm, right? An algorithm is a fancy word, but all it is it's a sequence of steps to solve a problem, right? So usually your programs are a bunch of little algorithms jumbled together to build some bigger thing, okay? So those are some bold words for us to ponder. And my question for you is, how do you make a peanut butter and jelly sandwich? What's the program for that? What's the algorithm? What's the recipe? Does anybody, like, I've forgotten, I have amnesia. How do I make a peanut butter and jelly sandwich? Somebody please tell me. Exactly. And so I'm going to pretend that that is the program and I am a computer. All right, so you got your bread. Here's a bag of bread that I am not very good at drawing. It'll be just a rectangular prism. There's little slices. Whee! And then, okay, you say I need to put peanut butter and jelly on the bread. So I, as a computer, will be like, all right, here is the peanut butter jar. I will place it on top of the bag of bread. Here is the jelly jar. I will also put that on top of the bag of bread. And voila, I have just ran your program, and I have made you peanut butter and jelly. Doesn't that look tasty? Is that what you wanted? Some of us, yes, probably. We'll just chew through glass and through plastic. But I think most of us would prefer the thing in this picture down here, right? So what's the difference? Like, why did the computer do this? Yeah, we didn't talk to the computer at the level that it needed to be talked to at. You kind of have to talk down to a computer. It knows how to do a bunch of things well, but they're very small chunks of things. We need to learn that. We need to learn exactly how to talk to a computer, and that is computational thinking. Okay? So we need to think in terms of operations that the computer knows how to perform. Okay? Which means we need to learn how to break down our problems into those smaller pieces. Yes? And we need to also keep track of the order, because order matters. Like, you need to take the bread out of the bag before you put peanut butter on them, right? Otherwise, you're just putting peanut butter on plastic. So I think a better program would have been something like, all right, get a plate, get a knife, get your bag of bread, get your peanut butter, get your jelly out of the jar, put them on the table, open up the bag of bread, take out 2 slices with your right hand, put them onto the plate, put the knife in your left hand, open up the peanut butter jar with your right, and dip the knife into the peanut butter jar, slide it onto the bread that you're holding down with your right hand, things like that. That's the kind of level that you need to talk to the computer at. Does that make sense? That's what I'm going to teach you in this class. Okay? That's computational thinking. Any questions about that? Does that make sense? That's the idea. So, yeah, here's a fun meme about this kind of vagueness that is implicit in our daily life. As humans, we're really good with vagueness. We can figure stuff out pretty easily, but the computer can't. Okay? So we need to learn that and when to do the right thing. Okay? How to express the right thing. All right, so here are a bunch of things we're going to be talking about later in this class. What algorithms are, how to make them, how to test something. Right? The algorithm is the recipe for the peanut butter and jelly sandwich. Testing your program is taking a bite of it, making sure it tastes right. We'll talk about the assumptions that you need to be aware of when you're writing a program, like what's part of the solution but not mentioned in the problem. Like you need the plate, right? You need the knife, stuff like that. Like if you want to light a birthday candle, for example, you can't sue the manufacturer when it doesn't work while you're trying to light it underwater, right? There are some implicit assumptions with most things in life, including programs. And then finally, computational thinking. This idea of thinking in order, doing one thing and then another, thinking very clearly so that you can express it to a computer, and then at the right level of abstraction, just right, so that the computer knows exactly what you're talking about. Okay, that's the goal. So I'll put a star right next to this, because that's where we want to go. Okay, we doing okay? Any questions? So what I want to do in this class, by the way I want to have this class happen is I'd like to treat it like a discussion. So please, if you see something and it doesn't make sense, yell at me. Raise your hand, ask a question, and we can have a discussion. Okay? I don't want to just talk to you for an hour and then I'll get tired and you'll get tired. That's not fun. So yeah, let's make it a bit more lively if you ever have something you want to talk about. Okay, you can derail me at any moment. But let's keep on trucking. Let's talk about the important parts of a computer, because why not? I think we've all interacted with these things. Maybe we haven't really talked about their names in a while, but you got your input devices to a computer. Those are things like your keyboard, your mouse, your touch screen, your driver, your wheel of your car, stuff like that. You got output devices as well. You got your display, your screen. You can print stuff out, 3D print even laser etch stuff. Plenty of output devices. And then where your programs will be running is inside this bigger box, right? You got the processor or your CPU, central processing unit. That's where your computer thinks. That's like the brain. That's the metaphor, right? That runs your program. Another way to say running a program is executing a program. You'll hear me say that word a lot. It's not like killing it or something. It's just running. It's another word for that. Okay. Then you have main memory, also called RAM, random access memory. That stores information about your program as it's running. So when you start to run your program, it gets copied off of your hard drive into main memory, and then the processor reads from main memory slowly but surely and executes your program. Okay? So very fast to access main memory. That's why you copy it off of the secondary memory, like your hard drive, your SSD, before you run it. And so that's why if you want to run more programs at once, that's why you need to buy more RAM, right? Because they all need to exist in memory if you want to be running them simultaneously. Yay! So those are words. You'll read more about this in your book. Let's talk about C++ now, because that is what we're going to be studying. You might be wondering why. I should probably motivate it to you. So C++ is a programming language. It's a very popular one. It was invented back in 1985, so it's older than most of us, including me, by a nice Danish man named Bjarne Stroustrup. I think that's how you say it. So he based this language on a language called C. And so there's a cute little metaphor, or not a metaphor, there's a cute little joke as to why it's called C++, and I'll show you that in a second. But it was based on a language called C. It's like a little bit better than C. That's why he named it like that. And it's what's called a high-level language. Okay? It's a high-level language, which means C++, when we write it, it looks more like English. It looks like we're writing an essay more than we're punching in ones and zeros on a magnetic disk or something. Okay? So that's nice for us. But that also means that if we want to run our programs on a processor, which needs things encoded in ones and zeros, we have to translate it down to that form somehow. Okay? And so that's the job of something called a compiler. C++ is what's called a compiled language. So there's another program that takes your file, your program. It looks like English, so it's like the blah, blah, blah. The compiler takes that, you give it to the compiler, and it outputs those ones and zeros that the processor knows how to run. It translates your program into something that the processor knows how to execute. Okay? And so let me write for you your very first C++ program. The simplest possible program is the one that does nothing at all. Okay? So let me write a program for you that does nothing. Ready? So I'm going to go to my terminal, make it large enough. And let's see, I need to be here. Code from class. I'm going to give this all to you. So let's go to CSCI 40. I'm going to make a new folder here called lec01. I'm going to go inside of that. And I'm going to have two screens. So I can edit and run at the same time. So I'm going to edit a file called, do-nothing.cpp. And here is your first programming example. Here's the simplest program that you can write in C++, one that does nothing at all. Okay? I have to say int main, so I'm just going to say words right now. I'm going to say them so often that you're going to get used to them. And I will explain them later, I promise. But it's good to have heard them once. So I'm going to make a main function. All right? You say int main. It takes no arguments or parameters right now. Then you give some curly braces to say, like, this is where it begins. This is the body of the main function, we say. Main needs to give back an integer. And a way to give something back is to use a keyword called return. See that becomes a pretty color. And usually, if a program exits correctly, you say return 0. 0 is like an exit code that means successful termination. Okay? And then every thought in C++ ends with a semicolon, so that's like the period in our language. And so this is the simplest program. It's a main function with one line inside of it, and it just ends that function. It closes the program, I'm done, return 0. Okay, so that is the simplest possible program, and I promise to explain it more later. Let me make it so that you can see it all. So that's the program, those 3 lines, and now I'm going to compile it and run it. Is that a good idea right now? I think I'm good with that. I'll show you this later though. G++ do nothing.cbp, enter, and that made a new file called a.out with a silly name, and I can run it. Press enter. Yay, it did nothing at all. I can run it again. Woo! That's exciting. So I just made a runnable program on my terminal, does nothing at all. Isn't that nice? So we're going to come back to this. I'll explain every little thing that I just did. But that is your first C++ program. Have that sink in. All right. Let's back up and go to the terminal now. Okay, because this is how I'm interacting with my computer right now. This is like how computers used to be, right? There were no graphical windows that you could move around. It was just all text on a screen. We're going back to that in this class. Okay, so this is right here. This is my terminal prompt down here in this window. Whee. So let me show you how to move around stuff. So thank you, past me. This is what your terminal will look like when you log into the class server, for example. And you'll have this little prompt, and it's going to ask you, like, you can type stuff over here and press enter, and then that's like supposed to be a command. If I press enter with this garbled text, it's like command not found, which makes sense, right? When you log into the class server, you will be plopped into a folder with the name of tilde. That's a shorthand for your home folder. That's like your own personal documents folder. So if I go there, this is exactly what you will see essentially when you log into the class server. You'll see a little tilde there, and it's like, that is your home folder. Okay? Once you're in your home folder, you can look and see what's there with a command called ls. Again, I'm going to give you all this in slides. You don't have to write it down, but I have to show you all these things right now so that you've seen them once. Okay? ls is short for list. It shows you the contents of whatever folder you're in, whatever directory you're in. That's another name for folder. So ls right now, if I press enter, it shows me that I have a bunch of little folders like this, called desktop, documents, downloads. For you on the class server, you have none of these. It's going to be empty. But you can add stuff. So that's ls. That shows you what's in your current working directory. There's always a concept of where you are. Okay? So if you want to know the full path to where you are, you can say pwd for print working directory. So I'm in my home folder inside of a lot folder inside of that. Okay? So the root directory in Linux is just a single slash. And then inside of that, there's a home folder. And inside of that, for me, there's a lot folder. Okay? That's how that's working. That's where I am currently. That's what the tilde really means. That's shorthand for my personal home folder. Okay? And you can move around. CD, you say CD for change directories. That changes your current directory for your current terminal session to be inside of that directory. Now you're working with files there. So if I say CD and give it a new place, like the root directory, just the slash, and hit enter, you'll see that the prompt changed. It's like, all right, you're here now. pwd says, oh, I'm right here. I'm in the very root directory of my file system. What's there? ls? Well, I get a bunch of these weird looking folders. And my home folder I know is inside of here. Like if I double click this, technically, and then if I went inside of the lot folder inside of that, then I would be back in my home folder. Does that make any sense at all? Please shout out if it does not. So I'm in the slash. I can go cd home. Now I'm inside of pwd again, slash home, right? Then I can go inside of that to my home folder, the folder with my username. Boop. And so now my working directory is slash home slash lot, which is tilde for short. Okay? You can always get back to your home folder by just saying cd tilde. Now you're back to where you are, back to your personal documents. That's where you'll be working on your things in this class. Okay? There are some shorthand things for CD itself. You can say ... to go out to the parent directory. So I'm in my, I don't know, let's go to my, my desktop folder. So I'm now in my home folder's desktop folder inside of that. If I want to go back out to my home folder, I don't have to type too much. I'm going to say cd ... That goes out one directory. Now I'm back in my home folder. cd ... again goes out one directory. Now I'm back in just slash home. Not in anybody's particular home folder for any particular username. Okay? Dot dot is your parent directory. Goes out. Then we have how to compile something. That's what I just did. We're going to use G++ to compile our C++ program. So you say G++, then the space, then the name of the program that you would like to compile. And that makes the machine code for it so that you can run it. G++ is short for the GNU C++ compiler. And GNU is like a free software foundation that helps you, that writes things like compilers. Very nice. Very nice people. So I was in my Windows desktop, or my home's Windows desktops, F22 code from class, CSCI 40, my lecture 1 folder. That's where I typed my do nothing.cpp file, and that's where I ran g++ do nothing.cpp. Hit enter, and it made the a.out file by default. That is the executable file associated with that program. It's the compiled form of it, the ones and zeros. And I can say /a.out to run something in my current directory, because the dot is short for your current directory. It's like, in my current directory, please run this a.out file. That's the syntax. And of course, nothing happened because the program did nothing, but it ran. Okay? That's how that works. And so, yeah, the / stands for, please run this thing that's in my current working directory. So that was a lot. You're going to study this slide a lot later, and I'll give it to you. But are there any questions about that? Just for now. Oh, I'm sorry about that. Yeah, we're a bit. These TVs are supposed to eventually work one day, but sadly they have not yet started working. So here, the G++, let's try to make it as wide as possible. If you say G++, then the name of the file, that compiles a file that's in your current directory, like I had to have it here, do nothing.cpp. So I said G++ do nothing.cpp, and it made or overwrote the existing a.out file. And so then to run the program, I say /a.out. That's what it looks like. Okay. Was that what you wanted? Question? This file that I was editing? Oh, I was doing fancy stuff. I can teach you that in office hours. That's not something I want to show in this class. It's called it's a terminal multiplexer is what it is. And it's very fancy. I will definitely teach it to you if you're interested, though. All right. So, back to full screen. Let's keep on trucking. So, yeah, I have a few things that I want to do still. And we need to leave at 5:45, right? Plenty of time. So, let's talk about editing code. So, you need to write files that are programs. So, you have to open up your program in the terminal equivalent of Microsoft Word or Google Docs. So, there are a bunch of different editors. Those are programs that you can use to edit files, right? So you can have a terminal-based editor or a graphical editor. Probably the easiest editor that's terminal-based is called Nano. And so I'd like you to get accustomed to that before I teach you the cool one called Vim, okay? So if you say Nano space the name of the file you want to edit, then that will plop you into this program that lets you start editing it from your terminal, okay? So Nano file name lets you start doing stuff. So if I were, for example, back up here on this terminal, if I say nano do nothing.cpp, hit enter, it plops me into an editor where I can move around with the arrow keys, change stuff, and then resave it with these little caret characters mean control. So if I type control G, it would give me help. If I type control X, it would try to exit back to the main terminal prompt. It'll also ask me, hey, do I want to save? Y for yes, enter for same file name. Okay, so that's nano. I'll show you that more later during the lab session today. And then there's Vim. That's the one I'm using. Actually, technically, I'm using NeoVim, but that's not a big deal. That's another editor, and that will give you street cred if you learn it. That's what all the cool kids are using right now. It's called Vim. So it looks exactly the same, pretty much, but there's more stuff for the programmers. Okay? Like I can easily move between those opening and closing braces, for example, in Vim. That's just another way to edit a file. And if you want to edit stuff graphically, I can help you install stuff on your own personal computer. Visual Studio Code is the most popular graphical editor these days, if you've heard of that. Okay? So that's editing code. I'll show you a lot of that throughout this class and during lab time. Let me also motivate C++ some more. So why are we learning it? I said it's a high-level language, so it looks like English, but it's technically on the low side of the high-level languages. So it's a bit closer to the CPU than other languages like Python or Java, if you've heard of those before. And so that's why we learn it, so that you get more accustomed to writing clean and fast code. Okay? So it's very fast language. It's faster than Java. It's faster than Python. And that's one of the reasons why all the cool kids like it. So every Adobe app, written in C++ for speed. All your major web browsers, all the engines that back them, written in C++. Most games that care about speed, like the underlying engine, for example, of a game, written in a lower high-level language like C++ a lot of the time. Okay? So that's why we're learning it. That's why we're teaching it to you. And it's one of the standard languages that you teach first. That and Python, usually. Okay? So, let's talk about compiling a little bit more. So that was the process that translates a high-level language to ones and zeros. So we had our C++ program. We had our do-nothing.cpp. And then we gave it to our compiler, which was G++. And the job of a compiler is to translate a single program file, a single .cpp file, into what's called machine code, or object code. That's the ones and zeros. Okay? And usually that's .o, and we'll talk about that later in this class. But there's actually a two-step process. G++ is doing both things for us right now, and we're going to care about those things separately much later in the class, but I at least want to tell you about it now. G++ is also linking things. A linker, in contrast to a compiler, is something that takes this machine code, a bunch of different pieces, a bunch of different programs, and links them together. Because eventually we're going to want to do cool stuff with our programs like print to the terminal, right? Show actual text, not just do nothing. And so we're going to need to include a library called IOStream. That's a fancy word I'll teach you in just a little bit. We're going to need standard : cout out of that to print something. And so this is all code that somebody else has written for us. And we want to link it with our program so that we can actually use it. So that we don't have to reinvent the wheel every time we write something. Okay? So that is what the linker's job is. To include other programs like libraries that have been pre-written. So the C++ compiler comes with some libraries, and those are just pre-implemented code that makes your life easier. Okay? You can think of it like a stack of books, a stack of programs pre-written for you. Okay? So after you've compiled, after you've linked, then you've got your a.out. Then you've got your program that you can run with the / on the terminal, right? / a.out. That is essentially the process. Okay? I don't want you to memorize this or anything. We're going to come back to it later, but I wanted to have shown you this right now so that when I show you this picture again, it'll be a little less scary. Okay? Are we good to move on? Because I definitely want to write some much nicer looking programs. Okay? Are we ready? To write a program that actually prints something to the screen. Okay, cool. So, let's write some programs. So the very first program that I am required probably by computer science law to teach you is a program to print to the screen the words "Hello World" as the customary thing to do. When you learn a language for the first time, you should always have a Hello World program because that teaches you exactly what like the boilerplate code needs to look like. Let's write a program that all you do when you run it is it prints it back to you. It says "Hello World" like it's become sentient and it's saying hello to you. Okay? So let's talk about that. Boop. So I'm going to get back to my terminal, and I'm going to make a brand new program, a brand new file in my Vim editor, similar to Nano, and I'm going to call it hello.cpp. Okay? And here's what I'm going to do. I'm going to get back to where I was, int main, braces, return 0, and I'm going to add some more stuff. At the start, I'm going to say include, with a number sign, include IOStream, and then inside of these braces, I'm going to say standard : cout, 2 less than signs, and some quotes, hello, comma, space, world, exclamation point, and then a semicolon, and that's going to be the program. So let me finally explain this for you guys. Okay? Let me go to my notes over here really quickly. Boop. Just to make sure I don't miss anything that I want to say. Yeah. Let me explain this program using what are called comments. Okay? So a comment in C++ is anything that starts with 2 slashes and ends at the rest of the line, or anything that's in between a /* and a */. That's called a comment, and it's just for the programmer. So if I write something over here after 2 slashes, this is a comment, okay? Let me do it over here. This is a single line comment. I can write whatever I want after those 2 slashes. It's just for me, the programmer. Compiler doesn't care about it. It doesn't look at it, okay? This is a single line comment. It's meant for programmers only. It's not code. Okay? Nobody cares. The compiler does not care about it. It's just for you to help yourself if you want to read your program later, if you want to ship your program to somebody else so that they can work on it. That's single line comments. And so if you want to start a new line with a comment, you need 2 more slashes. The comment goes until the end of that line. Okay, you can type whatever you want after those 2 slashes. You can also have what are called multi-line comments. That's these. You do */ be like this is, and then you can type enter as much as you want. A multi-line comment. And then you can type as many lines of comments as you want until you're done and you want to get back to code. You type */ to end it off. Okay, so those are comments. That's very useful for us. And actually, let's put that at the start and put this down here. Whee. So now I can tell you what each of these lines do. So this line includes a library. This includes a library called IOStream that gives us access to standard cout. Okay, because I use that down here. I say standard : cout, and then I do some stuff with it. All right. Then I say int main. What in the world does that mean? So this is called the main function. You're going to get very well acquainted with these words. It's okay if they don't make sense right now. They will soon. This is where the program begins. Okay? And so everything after int main, parentheses, you give some squiggly braces, and then inside of that, you put your program. That's essentially what you need to memorize right now. Okay? So standard : cout is the terminal string. All right? So if you give something to cout, you send information to the terminal string. This is supposed to be these 2 less than signs. They're supposed to be like an arrow. They're shoving data to the terminal string. That's why it's written like that. That's supposed to be the metaphor. So you're shoving hello world into the terminal, okay, into the output. And we are we make a lot of care. We take care to put the thing that we want to print between quotes. And that is called a string. Things between quotes, double quotes, are called strings in C++. Okay, that's a very important word that we'll get well acquainted with. I needed those quotes so that it actually printed the text and knew what I was trying to do. Okay? I don't really know why it's called a string. You can think of it like a string of like beads on a friendship bracelet that all have characters on them. That can be the metaphor. But that's just something. Text between quotes is called a string. Question? Yeah, we'll get to that in just a second. You can give anything to cout, but if you want text, it's got to be a string. That's all. Yeah, great question. I'm going to get there in just a second. So that's that, and then we have this return 0. What is that doing? This marks the end of the program. So if you return 0 from main, that tells the terminal, because the terminal is the thing that's trying to run your program, that your program executed correctly. The 0 is code for correctly. Okay? So that's the program commented up. And it's really only this line. These are the real code lines that the compiler is looking at. This one, this one, this one, this one, and this one. Okay? Now let's compile and run this. G++, or let me show you in a comment how to do it, right? So compile with G++, name of the file, hello.cpp, right? Let's scroll back down to the program. So G++, hello.cpp. And before I actually run that, sorry, let's delete it. ls, I only have hello.cpp right now. I have an old a.out. That's the one that did nothing. If I say G++ hello.cpp, now it's going to overwrite that a.out. Looks the same. But if I run it with a /, drumroll please, bam! Hello world down here. Look at that. Isn't that beautiful? Actually, it's not it's not very beautiful, to be honest, isn't it? Oh shoot, what happened? Where'd you go? Excuse you. That was weird. There it is. There it is again. So hello world. Oh man. So this is ugly. It like gave us our terminal prompt on the same line after it finished typing. That's not okay. We would like our program to press enter for us, wouldn't we? Because then it would look a bit cleaner. There's a way to do that. So when we run our program, we can add a special character in our string called \n. If we do this, that's one big character. It stands for new line. It stands for please press enter on the terminal so that the next thing that's printed appears on a new line. Okay? So this adds a new line for us. So if I recompile G++, rerun ./a.out, look at that. So hello world exclamation point, and then the terminal prompt happens on the next line after that. Isn't that lovely? That's how we want it to be. So that \n gets translated into an enter key press, essentially. Okay? There are a bunch of other of these called like escape characters. The \ escapes the next thing, so it's not really going to print an N, it's going to print a new line. \T is short for print a tab. \R does something really weird that I encourage you to try out. And then \\/ is how you print a single \ character, because otherwise it's waiting for something else. So if you want to print a \, you got to type actually two of them inside of your string. Okay. So that's that. Instead of the \n, there's also something called standard : end L, which is longer, but sometimes we prefer it. You can give multiple things to cout if you separate them with those arrows. So I'm giving the hello world string, and then I'm giving the end L string, which is, it translates to a new line character. So if I save and run, it does absolutely nothing new. Oops. Boop. So again, same program. Okay. Cout and what? And this, and L? Cout is the terminal screen. We're shoving information straight into this. This is the most important thing on this line. So this is the terminal screen. Like if I give something to it, it's going to print out and appear on the terminal. This text is being given to cout, and also this is being given to cout as well. Okay, this is short for a new line character, so it's pressing enter. The end L is just the new line character. I could have replaced it with just this. That's essentially equivalent. Yeah, good question. Any other questions? All right. Next thing. This is kind of ugly. We're using what's called the standard library, and so that's where cout lives, that's where endl lives. They're part of the standard library, so we have to qualify that with standard : It's like the standard library is cout, the standard library is endl. Wouldn't it be nice if we didn't have to do that? That's a lot of extra typing. There's a way. You can, at the beginning of your program, say using namespace std for standard, and that will make it so that you don't have to say standard : anywhere. And also, iostream gives us standard : cout and standard : endl, by the way. So if I say using namespace standard, then I don't have to say standard : anymore. I can just say cout. I can just say endl. That's quite nice. By the way, every line of C++, every normal line, this one's not normal, this one's not normal, but every little line of code like this one, it ends in a semicolon. That's like the period. I'm done with my thought in C++. Okay. That's why I'm including that. So this makes it so I don't have to say standard : anywhere, and so I can write things like this. Again, recompile, rerun, does the same thing. I think that is all that I wanted to do for this particular program. All right, so yeah, standard : blank uses that blank thing from the C++ standard library. That's something that somebody else wrote for us that we're using. Very nice. Okay. Let's also make a program that does simple math. Let's make a program that calculates the area of a circle with radius 5. Why not? Okay. So I'm going to make a new program. Am I good to go to a new program right now? We're comfortable enough with this one. All right, so back to the terminal. Vim, area.cpp. I'm going to make a new program. Include IOStream. So I want to print stuff using namespace standard so that I don't have to use standard : all over the place. Make a main function because that's where the program starts, and it should always end with return 0. And now I will see out the result of calculating the area of a circle with radius 5. It's pi r squared, right? So 3.14, and then multiplication in C++ is the star. So times 5 squared, so times 5 times 5. Yeah, and then a new line. Simple as that. Oh no, what's going on here? Oh, I spelled IOStream wrong. There we go. Now it's happy. So again, to compile this, G++, name of the file, area.cpp. It overwrote the a.out file, rerun it, hit enter, and that's apparently the area of the circle. We did some math now. That's what computers were invented to do. Any questions about that? Does it make a little bit more sense now that you're seeing it over and over again? All right. So one thing I want to say that's different from other languages like Python is white space, the spacing in between things, doesn't matter in C++. Like, I could have written the same program like this. Boop. I could do this all that I wanted to, and C++ doesn't care. Oops, that's not allowed. But you get the idea. That looks horrible, right? So I'm going to try and teach you good style, but notice that it's not necessary. I'd prefer you to write your programs like this, though. Okay. We good to keep going? Okay, so yeah, just pat yourself on the back right now because we just did some very cool stuff. We learned about our first programs. We went pretty far already. There are only a few more things that I want to show you before we have our break, and then we talk about, we connect to the class server and we all try this ourselves. But yeah, I just want to make sure we're all okay to move on, just for a little bit more information before our brains explode. Okay, so let's talk about variables, types, and input, because usually you don't just want to print the same word to the user all over and over again. So let's fix that idea. Let us create variables in our programs. All right, so here's how you do it. Let me make sure I am saying what I want to say. Dun, dun, dun. Yeah, I'll just say var. That's fine. So first of all, let's talk about what a variable even is. A variable is a piece of memory that you can give a name to. So a variable I like to say is a box in memory. So if you give a line like this, you say int x equals 42, that makes a box in memory called x that holds 42. So now I don't have to say 42 anymore. It's stored in x. I can just say x, and it replaces it with whatever's stored in that box. Okay? That's the idea of a variable. And every variable has a type. If I want to save a number, that's a whole number, I use the int type. Okay? So I want you to think of types like a cloud. Here's the int cloud. Whee. Things that are ints, things that can be stored in int variables, are whole numbers, like 42, negative 42, I don't know, 0, 8, all that kind of stuff. So negative numbers, 0, whole numbers, though. Those are integers, ints. If you want to store numbers with decimal places, you use a double type. So double is a cloud. You can make doubles, and those store things like 3.14, all that stuff. 12.0. Technically 12, but it knows that there's nothing after the decimal. Okay, it's a different type. It's a different way of storing information inside of a computer. Okay. Next, we have the char type. You can also pronounce this as char, I guess, because it's short for character, but I like to say char for fun. And the char cloud, you can put stuff inside of a char variable that is a single character. And those are things in between single quotes. Single quotes represent single characters. So you can have the capital A character. You can have the space character if you just put a space in between your quotes. Okay? Single quotes, though. Those are single characters. And then finally, you can have string variables where you can hold, a bunch of characters at once. That's all a string is. Okay? So hello, all that stuff. Capital the. You could even make strings with numbers in them, but it's a bit different than an integer. This is just characters. This is something you can do math on. Okay? There's a big difference that I'll show you later. But yeah, let's talk about variables and types and input and all that stuff. So let's make a new file called vars.cpp. And I'll include all this stuff again, include IOStream, using namespace standard, int main, return 0. And then above this, because return 0 is where the program ends, I will put a few lines. So let's make int x equals 42. Yeah, that's a whole number. Now I can output x. Cout arrow, because I'm shoving information that way into the terminal, x, and then also separate it with a new line. Okay, so that, if I compile and run it, G++, do I want to show you that yet? No. G++ vars.cpp /a.l, and it prints the 42. I only have to say x, though, because it's saved in the x variable. Does that make sense to us? It's just a way of not having to type something very long all over again. Yes.
You use int inside of the function, and there's a one int like outside of the function. Does those treat the same thing, or?
No, this is forced to be exactly this. The reason why is because we're returning an integer at the very end of main. That's the trick. We always have to say int main. It can't be like char main, double main. That's a great question, though.
So it always has to be in main.
Always has to be in main, yes. I can say double D equals 3.14. And then I can print D. Compile and run. Boop. Boop. Yeah? Then it prints 3.14. I can do char. Char C equals single quotes. I can make it be like capital A or something. Cout whatever the contents of the C box is, right? Just a box in memory. And it prints that single character, A. Okay? Strings are a bit weird in that if you want a string variable, you have to include the string library. So I have to say include strings with angle brackets in between. I have to include the string library to use the string type. That's just a weird quirk of C++. So string S equals, hello, in between double quotes. And then I can output S with a new line after it. Boop. All right, and that's the last thing in the program. After that, we return 0, which ends the program. So I'm just printing 4 different things, and I'm storing them into memory. It's a lot faster to say cout S rather than cout hello all the time, right? That's something that a variable is good for. Any questions about that? Let's see if I can show you the whole program at once. There we go. Boop. Are we happy with that? All right, the final thing that I want to show you today is CN. The last new piece of information that I want to show you today is CN. And that allows you to get input from the user to use in your program so that you have a different running program each time, depending on what the user types. That's very useful. So it's like the opposite of cout. You have CN. Cout is the terminal, CN is the keyboard. You get information from the keyboard, you send it to the terminal probably. So let me show you that. So CN, it works exactly the opposite to cout. So I'll make a new file called cn.cpp. And just to make it quick, I'm going to type all that stuff in the blink of an eye. And let's make a few variables. Let's make an int x variable and not let it hold anything yet. It's empty right now. X holds nothing right now. Not technically correct, but where I want us to go. All right, X holds nothing right now. And I would like to fill it with whatever the user types. With whatever the user types. Okay, so here's how we'll do it. I will say cout, hey user, enter, and int. And then I'll say colon. And then I will say cn. Remember that cn is the keyboard, and I want to send information into x. Which way should the arrow be going?
The other way.
The other way. Good. That's how you do it. That's how you get information from the keyboard, put it into x. And then you could say something like, all right, you typed space x or something. And L. Something like that. That is probably the simplest program that uses CN. Does it make sense why the arrow is the other way? It's all about the flow of information. Sorry, wrong file. Yeah, because this is the keyboard and you want to put information into a variable. And this is the terminal and you want to give information to the terminal because you want to print it. Yeah. Always think about the flow of information. So enter an int, I'll type 42 and hit enter, and then it got it and it put it into X. And now I can use it. And it's a different number every time I run it. So a.out, 55. You type 55. It's kind of ugly to have this colon and then you immediately start typing. So the standard thing to do is, this is the prompt, let's put a space right there. So now I'll say enter an int, if I recompile it, rerun it. Enter an int space, now there's room to type. That's kind of nice. Any questions about this? That's how you can get an int. You can do the same thing for other variables. Let's make, I don't know, char c, a double d. Start out empty, but we'll get stuff from the user. Enter, I don't know, enter a char. And then we'll type out this, and we'll get in the c. Enter a double. And we'll get it into the variable d. I have to say that they exist up here, though. That creates the space in memory. And then I can print them out. I can't hear you very well. Can you say that again? Yeah, that's the name of the variable. It can be whatever you want. So it'll be like, I don't know, my underscore double. Whatever you like it to be, as long as you're consistent. Great question. And now I'll print them out. I'll print out C. I'll print out my double. I hope that makes enough sense. And so here's the rest of that program. Recompile, rerun. It'll do all those things in order, right? Ask for an int, 42. Enter a char, capital A. Enter a double, 3.14. And then it prints them all out, because that's what I did after. I got them first, and then I printed them both out together. You see that? It's all about the order of things. This got input from the user and put it into the X variable. All right, that's probably the last thing that I want to melt your brain with today. Are there any questions about this program? Yes.
I think like you said, like when I use the char, like you use the single quotation mark.
Yes.
This example you didn't use it, and the program is ran.
Because I'm not explicitly giving the character, I'm asking the user for the character.
Okay, so technically I'm not assigning it. This is
That's right. The
okay.
CN is assigning it. The keyboard's assigning it, essentially.
Yeah.
That's a good question. Yeah. Any others? All right. So to end today's class time, then we'll have a break and talk about lab stuff. I would like to just make sure you paid attention. You didn't fall asleep too much. So please go to the by clicker page one last time. Let's do this lightning round. Tell me what a compiler does, please. What does it do? A, B, C, D. If you're definitely stuck, maybe you can pick E. I'll just give you like 10 more seconds. Hopefully we're already logged in. We're here till 5:45. Yeah. That should be enough time. All right. Boop. Nice. Yeah, the answer is definitely C. Translates a high-level language into machine code. That's what a compiler does. Does that make enough sense? It's all coming back to us. Takes your English-looking code, makes something that the computer can understand. All right? Let's say, let's not have writing it down right now. That would take too long. So maybe write it down on your own piece of paper. Let's make sure it's making sense, but you don't have to do this on byteclicker or anything. What is the terminal command to compile a file named x.cpp? Write it down somewhere so that you can remember it and have it come to your mind. Open up Notepad if you need to. I don't need to see it, but it's good to remember it. I'll give you 30 seconds. I did it a few times, but did you catch it? The program's name is x.cpp though. That's important. And then also, once you're done with that, write down what you would say to run that compiled program. How would you run it on the terminal? And then while you're thinking about that, let me make this small so I can do something silly for us. CSCI. Not for later. All right. What's the command to compile something? X.cpp. What do I say? Somebody shout it out. I definitely need to include x.cpp somewhere. What do I put on one side of this? G++. That compiles it with this name. And then, what file is going to get written with the compiled file, with the executable file that I can run? A.out. How do I run A.out? A dot and then a slash. So these are terminal commands. You type both of those on the terminal. This is not part of a program. That's how you run them. Okay? And I'll give you more experience with that when we do our lab time. But the very last thing for the lecture, at least today, is a cute little demo that I like to give just to show you that the stuff I've taught you just today can make for an interesting program. Okay? So I'm going to have our program sing to us. It's going to be a karaoke machine. And it's going to sing the lyrics to, of course, Frozen's Let It Go. And sadly, so that I do not get a copyright strike on my YouTube channel, I will be stopping the recording right now.